Hi everyone. Today I will talk about a survey of cybersecurity data, Infra, and how to simplify this with Iceberg. This is me. I'm the co-founder of and the CEO of PuppyGraph. Before that, I worked at Google F1 team, which is a unified SQL query engine inside Google, and TigerGraph, a graph database startup. So PuppyGraph is building graph query engine on your data. So it's a kind of a combination of my previous two jobs. We talk with a lot of cybersecurity company and working with half of the top 20 ones, and also a lot of startups. And we feel that there are some common problems the cybersecurity met in data infra, and mainly focus on cost, scalability, and performance. And the cost of scalability is very related to each other, since for cybersecurity company, everybody have a very large data set. So they have to be scalable with a relatively low cost. And then we also see the trend that a lot of them have either already migrated to Iceberg or have the idea or plan to do it. And some of them haven't heard about Iceberg, but after we make an intro, and they feel pretty amazing. This is what we want. Before that, they already worked on some metadata and the catalog layer by themselves, or they have a lot of workaround. But now they can just adopt it Iceberg to make it easier. Then let's directly jump into the survey, and some of the company name and logo have been hidden, so you can guess which company is using this architecture. This is architecture A, so Kafka will streaming the data into S3 and write it as a Parquet file, and then the user will use Athena to fetch the data from S3 and ingest into Redshift. And then use Redshift to support BI tool or their home build dashboard. This is because they are a big Amazon shop, and they believe Redshift is relatively fast, and also they don't care cost. You can realize that, and that's why they choose this one. And this is one of the largest cybersecurity in the world. Yeah. And we can see this is architecture B. So also the data is from Kafka, and it's streaming into BigQuery. It's mainly about logs. And at the same time, they have promises, which is matrix data. They want to connect it and find the relation between the logs and the matrix data. So they all import to BigQuery, and then Tabular and Looker or other their home build dashboard can leverage the data. This is also a very famous one, and recently got IPO'd. And this is the architecture C. Data is also from Kafka, and right into Iceberg. This is the first company we saw who is using Iceberg, and they use Trino to use for the offline analytic, and they use Droid to support their dashboard. And this is interesting because that Droid don't have native Iceberg support, so they built a data pipeline to load data from Iceberg to Droid, and use cron job to make it hourly updates. And this is architecture D. This one is also a big one, and the mainly of their application is on PostgreSQL. But at the same time, they want also have an analytical dashboard, and for their customer serving product. And at the beginning, they chose Snowflake because I think they designed several years ago. Snowflake is fast and cost efficient, but recently they realized that the cost is pretty high, so they're trying to reduce the cost. So they are doing the migration to Iceberg. You can see that it's in the process. So some of the data is in native Snowflake table. Some of the data is in Iceberg table. And so the PostgreSQL will CDC and do the data pipeline to both of the data source, since some table has been migrated already, some haven't. And this is the latest work, since it's from public information, so I can share with you. And this is a diagram in AWS for, I think, several years ago. And at that time, they also used Druid to support the dashboard, their customer-facing product, and also their homegrown UI. And after that, they realized that to load data to Druid is makes the data is not fresh and not updated enough. So they removed the Druid, and then we can see, since it's a little bit small, we rewrite it in the bigger diagram here. It's from Kafka through Kafka connector to S3. And then they use Amazon SQS and Airflow to hourly load into, or every 10 minutes to load into Snowflake, and then use Snowflake to support their customer-facing dashboard. But the interesting part is that the Laceworks product is called a polygraph. So it's a graph, but it's in table format, and they use Snowflake to support it. Then the problem will be the development is not easy. They need to write a SQL script with hundreds of lines. And at the same time, Wiz, now several years later after Lacework is popular, Wiz started. And they used Amazon Neptune, which is a graph database, to implement their security graph. So the product is very similar to each other. One called the Wiz security graph, another called the Lacework polygraph. And the CTO is a big fan of graphs, so he said the world is a graph, not a table. It's time for our tool reflecting this. And then with a much smaller engineering team to deliver much more feature. And then I think the big news this year is they acquired by Google for $32 billion. And I think last year, Lacework the valuation dropped from 8.5 billion to 150 million and acquired by Fortinet, which is a big change between the position since Lacework became the unicorn first, have much more engineers, and then later they didn't won the competition with Wiz. And here is one of the public diagram, and it's leveraged Amazon Neptune to serving their security graph. And I redraw the picture, the diagram as this. Maybe some part is not accurate. I just have some guessing based on the public one. So I think the Kafka is similar to writing to S3, and then use parallel bulking data loading to Amazon Neptune and serving the security graph. And here we see that is a combination of SQL and graph database. This is very interesting because that for most people in the SQL world, everybody knows that we should load the data from a database to data warehouse or data lake. You shouldn't load it in a reverse way, which means from data lake or data warehouse to database. But in the graph world, it's a common practice. Like if you need a graph, all the tools and product in the graph world are graph database. So you have to need to load the Iceberg team to Iceberg data to Neo4j and or Amazon Neptune. But the interesting part is that the scalability of Iceberg is much better than the other the graph database. So you need to pick up which part of data need to be loaded. And here's another very large cybersecurity company. They think the problem in a different way because their data is too big. So it's impossible for them to load data to a graph database. But they already have S3 and a Parquet, have Parquet file in S3. And they rethink about the problem, so they're trying to change the open source project, which is Janus graph from a graph database to a graph engine. So they replace the storage layer and to read the Parquet file. But the problem is that because Janus graph engine is designed for a database, so it's a single thread and cannot do parallel computing. So, and also is a single machine version. You have to fetch all the necessary data into one big memory. And now we reconsider about this problem. Since actually we are an outsider of cybersecurity maybe 8 months ago, but because different big cybersecurity company keep reaching out to us, and we learn a lot of the term from them. And we think that Iceberg is a perfect match for the cybersecurity. First is that we have a lot of streaming tools like Stream Native, Red Panda, and Confluent Tableflow. They can streaming data natively support Iceberg, and they can just directly streaming data into Iceberg tables. So the logs will be Parquet file in a very simple way, and it makes the data more real time, and the cost is pretty low. And at the same time, we as a graph query engine can directly query the object store since the data is in Parquet file managed by Iceberg. So we know the catalog, we know how to do the cost-based optimization, and also we have index can skip most Parquet file reading. Then user don't need to have a graph database. They can just have a graph OLAP engine, which is more match the use case for most cybersecurity company. And another lucky thing is that you don't need to choose between the SQL or graph, because you have one copy of data either in Postgres, Iceberg, and Delta Lake, and then you can use both graph query engine and the SQL query engine. So your output can be our input, and our output can be tables of nodes and the tables edges, and read by the SQL engine later as well. So for here, you can use Trino, ClickHouse, StarRocks, and a lot of others to serve the traditional dashboard. And at the same time, you can find attack paths and also do some root cause analysis, which is very hard to express in SQL. So it's a good combination. User can benefit from different tools in different use cases. And then let me introduce how PuppyGraph working on this. First is that we are real-time graph engine. So what our target is that we want to be the Trino or ClickHouse for graph. So you can do either offline or online real-time analytic. And also we native support for OpenCipher and Gremlin, which means we are compatible with most graph database on the market. And the existing application can directly on top of a PuppyGraph. You just need to change the server IP address. And we don't need to do the data loading. And since usually the customer data is super big, and it's very hard to do the data pipeline. And also we can scale to petabytes, which is very different from most graph database, because they're trying to have transactional updates on very large, on very high QPS. So you have to be row-based and have to be in single machine. And then we can see what's the benefits we can get by the graph. And we basically follow what Wiz do, since Wiz is a perfect case study for us. And we write a blog how to recreate Wiz by PuppyGraph. And we see a lot of cybersecurity architects read the blog and repost the blog. First is that find the network interface are not protected by any security group, along with their associate virtual machine instance, as this instance may pose a security risk. And we can see that it's about several lines to express the complex relations. On the right side is the graph schema we created on the user tables. And we can see that there are user, internet gateway, VPC, subnet, and a lot of entities. And we can also have some relations like access, gateway to, contains, host interface, and pretext. And physically, there are still tables and can serve other dashboard by ClickHouse, Starox, and others. But at the same time, you can find some attack paths. This is the second query. It's called find all public IP address exposed to internet, along with their associated virtual machine interface, security group, subnet, VPC, internet gateway, and the users, displaying all these entities in traversal paths. Here we can easily find some security paths, and the user will know, oh, here there is some risk, and here there's exposed to something shouldn't be exposed to public IP. And the query 3 is find rules that have granted exclusively access permission along with their associated virtual machine instance. And the last one is find a security group that have ingress rules permitting traffic from any IP address to sensitive ports, and retrieve the associated ingress rules, network interface, and virtual machine instance in the traversal plan. And of course, there are some other use cases can be used for graph, like banking and like fund flow analysis and anti-fraud, anti-money laundering, and also some telemetrics analysis, like root cause analysis. Since we can see that since there are long-term problem is that why graph database is not well adopted. And we talk, since based on my work experience, and also we talk a lot of customer in my previous, when I was at Telegraph, and also after we created a public graph. And the common issue is that people have to rely on SQL first, but then they have some graph use case. Usually graph use case is the next step of the use case can be solved by SQL. At that time, if you have another data stack, or you replace the existing SQL, it's an impossible decision. But if we can be a friend of a SQL OLAP system, and we can make our partner usage more, usage increased, at the same time, we can make users have some use case cannot be implemented before. So we talk with a lot of customer, and also talk with a lot of partner to write some combined use case study to provide some common practice for different use case. And also there is we collaborate with Dremio, Mean.io, Filetrain, and Confluent to write an ebook. And I think the other several speakers will show this QR code as well. It's totally free to download. And any questions? Okay. Thank you so much for the opportunity. Yeah.